More elimination is our second toolkit entry on the strategy of solving a system of equations using elimination. In our first entry, we had a system of equations that was ready to go. Ready to go meaning both equations were in standard form, and we had a pair of opposite coefficients, in this case positive 5 and negative 5. That meant when I added the two equations together, those opposite coefficients added to 0, or those terms with opposite coefficients added to 0, giving me a one-step equation that I could solve for half of my ordered pair. In more elimination, I first have to do some work before I can add the two equations together. Let's look at this first system of equations. In this system of equations, I don't have opposite coefficients. What I have is matching coefficients. When I have the same coefficient in front of a variable, when I add the two equations together, I don't have 0. So 3y plus 3y is 6y. The y variable terms are not adding to 0 and are not eliminated. I could subtract the second equation from the first equation, but I wouldn't like you to do that, mainly because it's really error prone. Usually students forget that they're subtracting each and every term and only remember to subtract the first term. As a result, instead of subtracting, I want you to multiply both sides of one of the equations by -1. I could multiply the first one by -1. I'm going to go ahead and choose to multiply the second equation by -1, just because I have some space under that equation to do work, to show my work. So -1 times 6x is -6x. -1 times 3y is -3y. And then -12 times -1 is +12. Now I have what I was hoping for. I have a pair of opposite coefficients that when I add the original equation to the transformed equation, to the second equation transformed, will add to 0. So let's do that. Original first equation, 4x plus 3y equals -6. I'm going to add that to the transformed version of the second equation. -6x minus 3y equals 12. Oh, I am so sorry about my handwriting. That is a y. So when I add these together, I have 4x plus -6x, which is -2x. This should seem really familiar because from here on out, it's exactly like basic elimination. 3y plus -3y is 0, so I don't need to write anything there. And then -6 plus 12 is 6. The inverse operation in my one-step equation is I divide both sides by -2, which gives me x equals -3. Of course, I'm only halfway done, but I do have half of my ordered pair, which is x equals -3. To find y, it is just like in my other basic elimination toolkit. I need to plug x equal to -3 into one of my equations. I'm going to go ahead and plug it into my first equation, plug -3 in for x here, just because I usually use the first equation. So 4 times -3 plus 3y equals -6. My first step is always going to be to multiply. 4 times -3 is -12. Once I multiply, I have a two-step equation that allows me to solve for y. Hopefully you guys have a little more space than I do. I'm adding 12 to both sides, which gives me 3y equals -6 plus 12, which is +6. Final inverse operation, I divide both sides by 3, which gives me y equals 2. I don't know what happened. I am done with this system. My solution to my system is the ordered pair -3, +2. X is -3, y is +2. Since I used this first equation to find y, I'm not going to check with that equation. I'm going to check with the second equation. And I'm going to use my untransformed, my pre-transformed version of that second equation in case I made a mistake when I was transforming. Does 6 times -3 plus 3 times 2 equal -12? Does -18 plus 6 equal negative 12. Yay, I'm right. So I have checked my solution by plugging it into my second equation. Yes, negative 3, 2 is a solution to the second equation. I will check the first one just to be safe. 4 times negative 3 is negative 12. Negative 12 plus 3 times 2 is negative 12 plus 6. Negative 12 plus 6 is negative 6. Yay, I didn't make a mistake over here. So that's my first case of more elimination, where I have matching coefficients, so I need to multiply one of the equations by negative 1. The second case is where I need to multiply both sides of one of the equations by a constant so that elimination is possible. If we look at this system, it's a great candidate for elimination. Both equations are in standard form. I just have to do one step first before I eliminate. I have an 8 and a 4, and I have an 8 and a 9. There's nothing I can multiply 8 by to get 9, and there's nothing I can multiply 9 by to get 8. Let's look at this. Can I multiply 8 by something in order to have a matching or an opposite coefficient for 4? I could multiply it by a fraction, but I'm not going to do that because that's really error prone and problematic if any of these terms are odd. Instead, I'm going to say, hey, look at this. I have a 4. 4 is a factor of 8. I can multiply 4 by what number in order to set this system up for elimination? Think about it while I'm writing parentheses. What can I multiply this equation by? The answer is almost 2. So if I multiply this equation by 2, this side of the equation by 2, I'm going to have an 8x, which is what I'm looking for. And then I'll have to multiply both sides by 2. I don't want to just multiply it by 2. I want to multiply both sides of the equation by negative 2 because then I won't have to then transform it again and multiply by negative 1. So I want to multiply the second equation by something that gives me an opposite coefficient. 2 is not quite going to work, then I'm going to have matching coefficients. I want to multiply the second equation by negative 2 because that gives me negative 2 times 4, negative 8x. That is what I'm looking for. Multiply this term as well by negative 2. 9y times negative 2 is negative 18y. And then 11 times negative 2 is negative 22. Oh, I am not going to have a lot of space here. So I have 8x plus 8y equals negative 8, just copying over that first equation. And now the second equation that's been transformed. Negative 8x minus 18y equals negative 22. From here on out, it's just like basic elimination. 8x plus negative 8x is 0. I don't have to write that 0. 8y plus negative 18y is negative 10y. Negative 8 plus negative 22 is negative 30. And just like always, that first step is really straightforward, and I have my first half of my solution. Y equals positive 3. I'm going to write that here. Ooh, what did I almost do? I almost made a great error. So even though I found this part of the solution first, I'm not going to write 3 first. 3 is the coordinate of my y value. It's my y value, 3, not x. So even though I found it first, I know the second half of my ordered pair, y equals 3. I'm going to just use the first equation like I normally do. 8x plus 8 times 3 equals negative 8. Multiplying first, 8x plus 24 equals negative 8. Subtracting 24 from both sides, I have 8x equals negative 32. I really hope this fits better on your toolkit than it did on mine. Okay, so I plugged 3 in for y, multiplied, two-step equation, inverse operations. I know that the solution to my system is x equals negative 4. I just found that second half of the ordered pair, and y equals 3. I'm going to continue with this hideous green outline. Now, I know you do not have room in your toolkit to do the check, so I'm just going to talk through it. I used that first equation, so I'm pretty confident. 8 times negative 4 is negative 24. Negative 24 plus, oh my gosh, 8 times negative 4 is negative 32. Negative 32 plus 8 times 3 is 24. So negative 32 plus 24 is in fact negative 8. Check. 4 times negative 4 is negative 16. Negative 16 plus 9 times 3 is 27. Does negative 16 plus 27, let me check. Does negative 16 plus 27 equal 11? Not 111. Yes, it does. All right. So second case, I need to multiply both sides of one of the equations by a constant in order to create opposite coefficients. So my goal, which I accomplished, was those opposite coefficients. My last one, just like I have done in all of my more of the algebraic method toolkits for more y1 equals y2, more substitution, and now more elimination, I've given an example of a story problem which can be solved using this strategy. So when you have a story problem that is represented by two standard form equations, that is going to be a more elimination situation. This is a great example for you to have in your toolkit because it is one that students struggle with. So you have 50 cents in nickels and dimes, where X is nickels and Y is dimes. Think about what is wrong with this equation, which is what I see all of the time from you guys. X plus Y equals 50. You have 50 cents in nickels and dimes. No, this would say you have 50 coins. You have 50 nickels and dimes together. Instead, if we have 50 cents, we have to take into account how many cents each type of coin contributes. So a nickel, which many of you don't know, you've never seen a nickel before, a nickel contributes 5 cents, and a dime is 10 cents. So we have each nickel 5 cents, each dime 10 cents, and that adds together to 50 cents. The second equation is like that first one that I wrote. I have 8 coins, so that's going to be X plus Y equals 8. This is a really, really, really common sort of story problem, so you should make sure that you understand it. In my work that I've shown, I wasn't just ready to go for elimination. I don't have a pair of opposite coefficients, so I multiplied that second equation by negative 5, both sides by negative 5. That gives me a 5 and a negative 5. I could have also multiplied both sides of the equation by negative 10. That would have given me opposite coefficients of 10 and negative 10. And that's pretty common. It's often the case that there is more than one correct multiple. Here's my work. I showed the addition of the original first equation to the transformed second equation. That allowed me to solve for y. And then I plugged y. Oh, it's great that I chose this equation, the x plus y equals 8. That's a lot easier. I plugged in 2 for y, and that gave me x equals 6. So the solution, the mathematical solution, is always an ordered pair. The meaning, in terms of the story problem, we need to talk about what x and what y stand for. Since I don't have a lot of room, I'm just going to write a number and a unit. So this means my x is 6. That means I have 6 nickels and 2 dimes. Does that make sense? 8 coins, yes. Do I have 50 cents? 6 times 5 is 30, plus 2 times 10 is 20. Yep, I have 50 cents.